Okay, so let's get started. It's a pleasure for me to welcome you here all in Berlin. So this is the first session of this IETF meeting, and this is the working group that deals with IP protocol version number 6. As if you think that 17 is better than 6, then you will have plenty of opportunities in this IETF, but not necessarily in this meeting here. So my name is Michael, and Pasi is the other co-chair here. This is an IETF meeting, so the usual note well applies. Most of you will have seen this before, so in general, there are a couple of circumstances in which you may want to think about what you say, specifically regarding IPR. So please take note of the note well. We have a note taker, which is Gori, and I think Pasi will take care of the jabber. And in general, if you go to the mic, please say your name so that the note takers know who you are. Then we have a pretty full agenda. So Tcpm has not met in the meeting in Buenos Aires. So we apologize for that. This was basically to the fact that the chairs couldn't make it. So as a result, we have a relatively full agenda today. So we will basically start with the status update of the chairs. Then we have 2 slots on the working group items, and then we have a bunch of new work which will go through step by step. Given that the agenda is relatively full, I would ask the speakers to focus their presentations on the things that need to be discussed here in the meeting, so that we have actually time to discuss things. Are there any comments on the agenda? Okay, then I think we should be good with that.
Just very quickly, so Praveen and I this morning submitted an update on data center.
Yeah. We can come to that on the next slide, actually.
Sorry.
Also, maybe one note, as we added the last 2 presentations relatively recently, because those drafts were submitted relatively late to us, but we still believe that this is interesting content, so we added them to the agenda. So we had recently 2 new RFCs, the RTO restart one and the undeployed one. So that's more or less the usual thing that we do. And then this is the usual status update on the working group documents that we do in every meeting. So for 2 of them, we will have dedicated sessions after this year. For the other ones, I can quickly go through the status. So as I said, for 793 bis, we have a slide from Wes after this talk. For the EDO draft, Joe currently has new implementation efforts, both on Linux and FreeBSD. And the current plan is to wait the outcome of these implementation efforts before deciding how to move forward with EDO. Then Lars already mentioned for data center TCP, actually the slide is outdated already. So there was an update this morning, which was relatively recent. So the chair's plan is to start a working group last call for data center TCP relatively soon, simply because we see other work in that space. And we think that for that, it would be useful to document the current state as it is deployed. So I strongly encourage everybody to have a look at the most recent version that was submitted this morning. And if you have any concerns that speak against the working group last call of this document, it would be good to let us know relatively soon, because we will, I have to read the newest version myself first, but in general, we plan to run a working group last call for this document very soon, maybe even if nobody speaks up, maybe we will even start one this week. So we've not decided on that, but in general, if you have any concerns on this new version, please have a look at it and please speak up now, because otherwise we will start a working group last call. You might do something similar for Cubic. There's a pending update for that one. As far as I recall, there have been some minor comments actually on the list. But for that document as well, actually, I mean, this is an implementation documentation, so it doesn't make sense to wait forever. So the plan would be that as soon as we have an update, that we review whether we can directly head to last call. The Accurate ECN one is a newer draft, so I think Mirja is still working on implementations for that, so there's no update on that one. And for the RTO consider, we will have a dedicated slot later in this meeting. Are there any comments in particular on the documents that we have that we will not discuss later in the meeting? Okay, I don't see any comments. So then is Jana in the room? Okay, so Jana asked me for a very quick heads up.
Thanks, Michael. So my name is Jana Iyengar, and I'm here to advertise a BOF that is going to be happening on Wednesday in the morning. The BOF is called Quick, and it's about the BOF is a proposal to standardize to create a working group to standardize a secure transport for with an initial target of HTTP as the application. If you know about this enterprise and want to support it, please show up. If you don't know about it and want to learn about it, please show up. If you know about it and don't want it to happen, I invite you to look at the agenda for the many other sessions of fun to go to.
Okay, I want to remind you again, so this is the working group for IP protocol versions, for the IP protocol number 6 here. 17 is a bad idea. This is a quick update from WES on RFC 793 bis. So the bottom line is that WES continues to work on it relatively slowly. So that's why there has not been too much progress recently. So WES plans to submit a new update hopefully this week. So there is an issue tracker in there. You can see the URI on this web page. So you're encouraged to have a look at this and let us know, or let in particular WES know if you think that things have to be added. One specific comment from WES is that there are cases in which it's not as obvious how to add text to 793 bis, for example, from other documents. So in some cases, more editing is needed than we originally assumed. So this can result in some review that has to be done here in this working group. But other than that, we basically wait for a new draft update. Are there any comments or suggestions on that one? Okay.
Sorry, I have a working group meta comment. Did we find a primary note taker yet?
Yeah. Cool.
Okay. Oh, Gory. Excellent. Cool. Thanks.
So yeah, Gory is the primary note taker. You are the secondary.
Okay.
I'm yeah.
Okay, so then I think we can directly move on to the RTO consideration. So this is a document that was discussed quite a bit on the working group, and that's why I've basically asked Pasi to have a look at the discussion and to make some proposals how to move forward.
Okay. Yeah, so retransmission timeout requirements. This is a draft by Mark Ullman. But I should note that the presentation is by us chairs. So Mark has been offline recently, so he hasn't had a chance to comment this presentation. So something you should know for the following presentation. And we haven't had a chance to check with him about the slides. So that as a boilerplate for this. All right. So the draft is about giving high-level requirements, protocol-independent requirements on RTO behavior based on how TCP RTO has been working. And it specifies some relationships to the other specifications, such that the currently standardized methods are not updated or obsoleted, so they continue to exist as before. But the future standards should follow these guidelines and requirements that are given in this document. And there's also a note that if a protocol design is not directly applicable to the requirements, then there is a need for alternative specification, more specific specification. And there are some reasons we want to move forward soon with this, so it would be nice if we can form a consensus and get forward with this. Right. So about the requirements quickly. So these are pretty obvious if you know how RTO works. So if there is no prior knowledge of latency, then RTO must be set to no less than 1 second, as it is with TCP. Then there are some fairly generic language on how the RTO should be set based on the current measurements of the round trip time. So it must be based on recent observations of feedback time, as it is called in the draft, and take the variance into account. So these are the kind of the guidelines that are given very broadly. Must be taken regularly and must not use ambiguous samples like for retransmission. So very obvious based on what TCP already does. And then there is a statement that RTO must back off exponentially if there is a loss, or if we cannot get response to the retransmission timeout. And it must be taken as an indication of congestion. And this is also not very specifically said what is done in response to congestion, but then that's a matter of other documents. So these are the requirements, fairly high level, and kind of give the boundaries under which RTO should work. All right, and then there has been a bunch of discussion recently, and we kind of found three maybe main issues we wanted to highlight now. So the first one is the relationship to the existing TCP RTO specification. So there is a small bit of language in the beginning of the specification that indicates that this is a mandatory algorithm for TCP. And RTO guidelines kind of seems to loosen this requirement. So there is a language in the abstract of the RFC that says that it upgrades the requirement of supporting the algorithm from should to must. And this original language comes from 1122, and this RFC 6298 upgrades this to must. So it requires the supporting that RTO algorithm, at least in the system. And that might not be the case in all implementations currently if you have been following the scheme. So kind of the first question here we want to get some input from you is that is RTO considerations in that case, is it an update to RFC 6298 as it was suggested in the list? So it seems to say that implicitly seems to say that this must that originally was in 6298, it kind of is somehow undone or downgraded back to should or even may, if we read how this document RTO considerations spells it. So we would appreciate input or opinions. Do you think we should actually tag this as an update to this proposed standard that is 6298?
Mia Kulevin, is this one? Yeah. I think this is the wrong question to start with because the scope and the applicability of the document is not fully clear yet. And as long as we don't know what the document is actually supposed to say, it's hard to answer this question.
Okay.
That's the last question in your list. Maybe start with the other ones.
Yeah. They are not maybe easier, but All right. Yeah, it's true that this is like more like a broader scope document, and that's, I think, what is the intent of this document. Yeah.
Just one comment. I mean, one of the reasons why we have flagged this first is that at least our impression so far was that the applicability to TCP is non-controversial. So a lot of the discussion is how this document relates to other protocols. But for TCP, actually, at least our impression was that the guidelines and the fact that there are implementations that actually have algorithms that fulfill those guidelines, but not the standards specification. So we feel that there is a certain consensus on the guidelines apply to TCP. The question is more formally whether we update the spec or not, but we can delay that question afterwards.
Mia Kulevin again. So then I have another question, because actually, if you just change it from or like the document is more general, and the document says must, should, but the TCP document is specific to TCP and it says must, so this is actually nothing you need to update, that can stay as it is. It's a must for TCP and it's a should for everything else.
I think one intent in this document is kind of, the way I see it is to kind of legalize future experimentations of other RTO algorithms.
Depends what we write in the document.
As long as they stay within the boundaries that are basically given here.
Christian Wiedemann from Microsoft. I'm speaking here not so much for Microsoft as for the general feeling now, is that the algorithms that we have in 6298 is a compromise between implementation convenience and the desired result. It makes hypotheses, implicit hypotheses about the probability distribution of the reconstruction data, etc. So I think that the must is actually weird. So I would not be too worried if we relax that must, because really what we have in the text today is a compromise that was based on the computing capability of a computer 30 years ago. So hey.
Okay, I hear you. Yeah, okay. So this was the easy question. So then there's another document in progress called UDP guidelines. And it also gives guidance about RTO. And it seems that these guidelines in UDP, the UDP document and in this RTO guidelines documents, they seem to be compatible as far as I can read. But they are two separate documents, so that's a little bit an ideal situation. Currently, the RFC 5405bis refers informatively to RTO considerations. But RTO considerations does not do the opposite. And the situation is that the RFC 5405bis is already past IETF last call, so it's kind of far ahead this document. And ideally, we would like the guidelines to remain compatible if we move forward. So, well, the question here is: should we, in RTO considerations, should we more strongly refer to UDP guidelines and informatively refer it as the primary UDP reference that should be followed to give the readers the pointer to the right direction?
David Black, TSVWG chair, which is where the UDP guidelines draft is, and also Lucky Shepherd for the UDP guidelines draft. I think the answer to the question you're asking is yes, but let me explain what I think ought to be happening so we can make sure we're clear. This draft, RTO considerations, is a fine statement of design principles. As such, it's a very good draft. It ought to go forward. However, the normative statement of what to do when you're writing a transmission-like protocol over UDP and all the things you need to pay attention to, that's 5405, and it should be 5405 bis. And on that basis, I think the answer to your question is yes, and I would back it up with, and RTO considerations should not be making any normative statements about UDP. Those all belong in 5405 bis, please.
Right. Any other opinions or additional opinions? Yeah, and yeah, okay, so that sounds clear. So, and then this is kind of one of the reasons we said in the beginning that we would like to move forward quickly if possible. So that's kind of something that is behind this. So we have this relationship between the two documents.
David Black again. +1, big +1. I do not want to be standing at the microphone in a TCPM meeting in Seoul talking about why this has stopped 5405 bis moving forward. We need to get that draft published pretty quickly.
And of course you make your own decisions in TSVWG whether you, yeah, how strong findings you want to keep this direction, but right. Okay, so hopefully this makes things happier in the TSVWG front. And then we have the last, but not the least issue, maybe. So there has been some discussion about one of the scoping bullets in the document, which relates to future implementation freedom. Let's call it R3. So the text has been changing from one version to another, but the current text says that alternatively, future RTO mechanism implementations may be made directly against the requirements in section 3 without another protocol specification, meaning the requirements that I stated a couple of slides ago. So I think the intent of this text is to give the designers of future RTO mechanisms the freedom to experiment with things, and kind of as long as they remain within the guidelines of this document, it kind of hints that they are free to do so without causing danger to the internet or things like that. Okay, and there has been a lot of discussion about this, and what does this actually imply and what does this actually mean? And okay, so one recent proposal was from David. It seems like a very small wording change, but it actually changes the meaning. So it's a significant change. So instead of changing the future RTO implementations of maybe current mechanisms, the new text would state that alternatively implementations of future RTO mechanisms may be made, and so on. So small change, but it seems to improve the text quite a bit. And I think Mark agreed with this, so it seems that there might be consensus here, unless people disagree. There is another proposal that was in some course of the discussion was to remove this RT entirely because it seemed like unnecessary thing to say even. And that's another option to go. I think the author disagrees strongly about this option, but that was something that I think at least a couple of people made this point in the mailing list as well. So any inputs on this? We are not going to be voting on this because votes on complicated topics bring surprising results. Yeah.
So I like David's proposal, and I like it because I spend a lot of time with Cubic and Data Center TCP to actually get stuff specified that people are deploying. And this seems to be going exactly against that, that you can just do stuff in code and don't tell us what you're doing, which is not what we want, right? We want to let people innovate on the code, but we would actually like them to also describe what they're doing and what experience they've gotten with it. So I support cutting that statement.
You support cutting that, or?
Yes. I support David's proposal.
David's proposal is not cutting it.
Yeah. Next time, make sure that we're not the furthest room from the coffee on Monday morning. Actually, I support the bottom bullet.
Okay.
Gori first, seeking not to be confused and taking the right notes. I'm not so happy about just saying, and go and do anything else you like afterwards when we're trying to encourage people to publish documents here to document what they're doing. So if we want information documents about real implementations, I go with the last one here. Don't encourage people to do things, encourage people to do it, come document it here after they've done it, or before they've done it, or something. At least tell us.
David Black. So my proposal, which Mark has agreed to, was a defensive move to try to defang what Mark had originally written as draft, which I did not like. My proposal is not something I'm proud of. It makes it minimally acceptable, and I actually agree with Gori. I think this is a process requirement, a technical document. It doesn't belong here. I would strongly support removing it.
So I know that the author is working on another update, and I think I'm not sure what he will do at the end, but like the end of the discussion was mainly about where to use normative language and where not, and using normative language about what we impose to implementations compared to what we say in the spec is something we never have done and might lead to confusion. So I hope by changing the normative language here, we can actually resolve most of the problems. The author might still want to have a note about, implementations in there, but it should be in a separate non-normative part. And I guess we just have to wait for the update.
Okay. Yeah, and as I told, so we don't have the author in the room, so we we have the easy task of convincing him about this. So.
Actually, no, we don't, because it's a working group item and he's
Yeah,
the
of
editor.
course.
And
Yeah.
if we decide that this is what we want, he better edit it in there, right?
Yeah. Okay. Exactly. You're right.
And I mean, at that point, it's like it would be probably we have to remove him as an editor and find a new editor.
Well.
But like we should still wait for the next update and see what we get.
Yeah, and I think there will be an update when Mark is back within a week or so. So there will be some progress fairly soon. And let's see. Which will, I don't know, make TSVWG chairs maybe a little bit nervous, but regarding the timing. But okay. That was the last. I don't have any concluding slides. We just wanted to get input on these three issues, which we believe are the main kind of open issues here. So what to conclude? Let's wait for the update. Still, there's some reason to hope this go forward fast, but we must wait for the next update and continue discussing the list. Because I don't, many of the issues seem clear, right? Or there seems to be fairly obvious way forward, but I think this last one is the kind of the most sensitive one.
So, David Black, this time on the UDP stuff. Over in TSVWG, and we'll talk about this. I think we're up on Wednesday with the guidelines, Gori. We'll talk about it a bit more. We have a sense of urgency about moving 5405 bis forward. So there are some open issues I think are very minor about conversion text 5405 bis with RTO consider. There is going to be a timeout on this. If we can't converge the text by the end of August, we are going to move 5405 bis forward, regardless of what RTO consider says. I hope the author understands that we're deadly serious about this.
Yeah. Yeah, and yeah, that's then what you will do, and then we act accordingly. So that's well understood. Okay, thanks. That was, I think, useful input. Michael, do you have anything to add on this topic, or should we move forward?
No, I think we can move on. Anyway, the document will be last call both in TCPM and TSVWG, so that's consensus. Okay, and this was the session with the working group items. So we now start the presentations on the new work, and we start with a presentation from Yu Chong on REC.
Hi everyone, today I'm here to present RAC. This is a revision draft since last fall. This is done by myself and my co-worker Neil Carwell. Next slide, please. So RAC comes from this motivation when I work on Linux TCP stack, and this is how many RFC and drafts and heuristic and whatever that it implements. And maintaining all these interactions among all these different techniques have become very, very difficult. And we have submitted many bug fixes. And I started to think that, does it really need to be that complicated? Do you need really that many heuristics to decide if a packet is lost? And do they even work well in today's traffic? And by me studying really in depth of all these algorithms, I start to sort of find a lot of them share a common sort of rationale behind them. And next slide, please. And that rationale is what I come up with. Is called RAC. Is to really use the timing information. And the principle is pretty simple, that you basically monitor the delivery process of every packet. You don't really care if it's a retransmission or original transmission at all. And then we take an example. A sender sends just two packets, okay? P1 and P2. And if P2 has been delivered, then you start questioning maybe P1 is lost. And if you want to accommodate reordering, then you simply put some kind of some fast factor of it. And that's it. Then you apply this general principle to every packet you send and receive. Sorry, not receive. You receive and act for it. And then you can really come up with this algorithm that just based on time instead of counting packets. And if you think of what is this redo-back that we are all familiar with, a do-back means, oh, something out of order has been delivered. If you don't have SAC, you don't know what is delivered. You just know something out of order is delivered, right? So redo-back is simply just sort of representing this reordering window by some kind of packet counts, out of order delivery packet counts. And there is another old draft that's implemented by Linux for many years. It's called FAC. FAC is essentially using this reordering window, setting it basically just to 0. So it's not very resilient to reordering. But it's all based on this similar principle of something I sent recently has been delivered, so something I have also sent around that time is probably lost. Next slide, please. So let me use this example again. Suppose you send 4 packets here, right? The time sequence graph that people are familiar with. And some of them may get lost. So next slide, please. So you get a SAC of the second packet, right? So you get an RTT of that packet, very straightforward. Then you start thinking, well, is the first one getting lost? Next slide, please. So what you do is you say, all right, when did I send the first packet? It was sent about an RTT, and you want to allow some kind of reordering window, just pick a number, say a quarter of RTT, half of RTT. And well, it's not quite lost. Maybe I should wait a little bit more. And all you do is you just arm a timer to say, at that time, I think I would say packet 1 is lost. Next slide, please. So when that timer fires, you haven't received any other X, then you just retransmit that packet and you declare the first packet is lost. So next slide, please. So then suppose now that packet, that retransmission actually gets delivered, and then you get a SAC of that packet. So then you start questioning, the second and the third and the fourth, are they lost too? And you apply, next slide, please. Then you apply the similar technique, right? You say, well, the delivery window I have set is that long. Apparently, this 2 packet has both been outside of that delivery window. They have expired. So you go ahead and retransmit that next 2 packets. Next slide, please. So that's how RAC actually detect tail drops in this case, because it doesn't matter it's a tail or it's the middle or the front. It's just based on the most recent delivery process, and you are just keep updating it. And it's sort of like every packet you stamp an expiration date on it, right? Except this expiration date, instead of full, which is stamp fixed, you dynamically update it based on your most recent delivery process. Next slide. Suppose you retransmit that 2 packet, and the first retransmission got lost again. So you only get a sack of that second retransmission, the last one. Next slide, please. Then you say, well, is that sort of that packet lost? You apply the same technique. And they say, well, not quite. It was just sent about that far ago. So you arm another timer. And next slide, please. When that timer fired, then you retransmit that packet. So RAC can detect lost retransmission too by just this simple approach. And if you think about this, in this somewhat complicated loss scenario, you can really come up a right due-back threshold to detect that. You can really count packets. Not to mention that most stacks today only apply that due-back threshold counters on originally sent packet. When you are retransmitting, that doesn't quite apply if you read the draft very carefully. Of course, stacks like Linux, they sort of improvise to say, well, that kind of also apply to retransmission. But anyway, just packet counting is just not a very good way to do that. Okay, next slide, please. Do you have a question? No?
Yeah, Lars, I have a question, but I don't know if you want to take it now or later.
Ah, sure, I can take it now. Yeah.
So what happens if you have a variation in your base RTT that's larger than whatever you pick for Rio wind?
So you said that, let's say, you know, this example, the new sacks actually come back much later or much faster.
No, so if your base RTT between the two, where your path RTT has a variance to it, and if that variance is higher than whatever you picked as the window time that you're waiting, it seems like you would unnecessarily retransmit quite often.
So in this example, the RTT is always the most recent RTT, and sometimes you can always get it wrong, right? You can never get it perfect guess. So in this case, RAC indeed will spuriously retransmit.
Right.
Yeah. So it's not like RAC can completely never have spurious retransmission. And in some cases, yes, in some like really strange reordering patterns, I do see that RAC incorrectly mark a lot of packet lost. Yeah.
Maybe we'll talk later and then you continue.
Okay.
Just a comment in response to Lars's question. You could also, I mean, right there it says the most recent RTT, but you could use some variant of that as well, which is like a max RTT, so that you don't have to actually incorporate variants in directly, but you could do something else like that.
Yeah. Okay. Just to comment on that, well, this is related, so maybe just let me go ahead. So why do RAC make sense? I just show you the tail drops and loss retransmission can be fixed by RAC. And in fact, these are very common in at least what we observe on the Google web servers because of the traffic is very structured. It's always this request response, including video traffic. It's all chopped, right? And the other one is called the traffic policing. There is a new SICOM paper that talks in detail about how this police traffic really interacts very badly with TCP. But part of that is a lot of times the repairs are also going to get lost again. And if you don't have this sort of RAC approach, you often easily get into timeouts and stalls. And why is the stalls dealing very badly with the policer is that most of these policer are token bucket based. That means that when you are not sending, the tokens are accumulating. And that means next time when you are sending, then you don't really see the limit. You see no limit because your bucket is pretty full. And then so TCP will actually slow start very quickly and it use all the tokens. And then you go into this timeout again and get a lot of losses. So it's just a very vicious cycle when you have RTOs with policers. And what RAC does is to use every packet information to recovery losses, so you can sort of reduce this kind of losses much better. Next slide, please. And now the two things is how RAC deals with reordering, which is related to Lars's question. So this is three type of reordering that we see on Google, and the first two are very common compared to the last one. So the first one is basically you send a burst of packet, and usually because the traffic is structured, the last packet is not an MTU size, it's some partial packet, and it gets delivered first. Then the rest got delivered in sequentially. So what you see is this like last packet get delivered first, and then the rest is delivered sequentially, and then you get a sack or at the very tail of the end of the window. And if you don't use rack of a reordering window, let's say you just use FAC. FAC is going to mark everything. In this example, P1 to P3 lost, and it's going to retransmit all of them. The second type is actually this small burst of reordering, like P456, then P1 to 3, then P9, 11, and then P7, P8, that kind of. And based on my sort of investigation, this has largely to do with AO2.11 and this black act that's doing sort of local repairs. But for example, it can send a burst of frames, which each frame is a TCP packet, and you will lose some of them. And instead of at the receiver, instead of holding this out of order packet to the, not to send it to the TCP layer, it sends it first. And then you're trying to repair the whatever lost ones. So from TCP receiver point of view, it's out of order delivery. And this is actually getting quite common as well. And oh, I forget to talk about the cost of the first one. Is very commonly because of router load balancing. And the router here could not be like a Cisco router. It could be just on the host. There's some kind of load balancing between, like, you know, packets sending to through different NIC to the outside world. And they basically just traverse a slightly different path. And the smaller packet in general gets forwarded faster. The last one is really the route actually shift from a longer route to a shorter route. And that's what you see reordering. But this happens fairly infrequently that it's basically not much to worry about. It's on the order of like at least tens of seconds or minutes. And rack really helped the first two, but it doesn't really help the last one. Because when your route is shifting that quickly, there's not much you can detect unless you have prior knowledge that, oh, your route is going to change from 200 milliseconds down to 5 milliseconds. Next slide, please. So back to the motivation, rack is really intent to whack out all this and replace them. And if you think you don't really need all this dynamic due-back threshold, if reordering increase the due-back threshold to A, something like that, or FAC, it kind of subsumes all that. And it works naturally with tail loss probe. Because it doesn't just work with tail loss, it works with any kind of probe packet. Because rack doesn't care what you send. It just look at the packet delivery process. You can come up with another active probing mechanism that sends some extra 2 packet, or you retransmit some packet in the middle, some crazy idea. Doesn't matter. Rack just use them all. Just use all the packet timestamps. Next slide, please. So we run a quick experiment of rack and FAC, and we did a multi-day experiment at the front end near Berlin here. Since we are here, I might as well, you know, experiment that. But this is actually in this place, all the connectivities are pretty good, but still, I think rack shows very good result. Next slide, please. So this is how much timeouts or RTOs it has reduced in different states in Linux. And since this is not in the IETF standard, let me talk about what those stats means. Disorder means you get some kind of due back or some non-normal act that's basically not sequential act that you are expecting, right? Not the next packet gets act. That means something's wrong, maybe reordering, there may be timeout, and maybe a lost. And rack really help on that to reduce the timeouts. And lost state means that you already have an RTO, and then you are trying to repair after this timeout events. And it's very likely you will timeout again because of this current TCP's incapability to fix that. And overall, the latency reduction, the total is about 4%, and the average is about 11%. And the reason for that discrepancy, first, is that actually rack involved more shorter recovery instead of less recovery, but it's usually like a much longer, like each recovery takes longer. That's why the average is better, but the mean is 4%. But again, here the connectivity is so good, there is not much to fix here. So that's why And there is a sort of surprise benefit for rack. That is, it actually reduces the TSO fragmentations. So for people who are not familiar with TSO in Linux is basically if you're trying to send 10 packets, you bundle them into one socket buffer, and then you send it to a NIC, and the NIC chops it into MQ size packet. And the reason for that is, if you can you quickly go back to the last time sequence slice? If you think of this, when I presented, every rectangle here is a packet, but it could just be a TSO size packet of each of them has 10 packets in it. And the nice thing about that is that every sort of this big jumbo packets actually share one send time transmission timestamp. So in rack, when it's marking a packet loss, since it's based on time, it's marking the entire thing lost. And that results in much less fragmentation, because if you are counting individual packets, 3 dewbacks and 5 dewbacks, you need to fragment those packets so that you mark one jumbo packet. Oh, the first half is partially lost, and the second half is not lost yet. So that's more fragmentation. Okay, can you go back to that slide? Yeah. Next one. Yeah. So that's no, I'm not done. So that's this nice thing about that, and we actually found some two sort of optimization. We could have further improved that, and we're looking to see the new result. But that was discovered last Friday, so we weren't able to refresh the result yet. Lars, go ahead.
Yeah, Lars Eckert. I wonder if you have stats on how many more retransmissions you're seeing with rack, right? Because this might be, so I can do super well here if I just send everything twice.
Yes. So the number of retransmission in terms of the differences in delta is like 0.5%. I can quote the real number here, but basically it's about the same.
So that sounds good, right?
Okay.
Because that's way less than what I thought it might be, which is great. Because especially also this, if you're marking the entire TSO chunk, right, you might retransmit a lot of extra stuff that wasn't actually lost.
Yeah, that's a good point. I should have include that data. Yeah, but basically they are almost identical.
So what are your little, you say star, we expect better from 2 recent optimizations. What are those optimizations?
So basically, I forgot to mention that in the latest draft, we have this optimization. So one problem with a rack timestamp is that it's microseconds. So imagine this case where you send a TSO packet of 10 packets actually, and then you get a stack of say number 5, right? And so if you are just comparing, maybe that's not a good example. So basically the optimization is to say that in the case where you have limited resolution of the packet timestamps, you can use the packet sequence as a tiebreaker to make the timestamp sort of a much finer granularity at the TCP level. So that actually detect a lot more losses, and which we have, we just discovered that and we haven't implemented. Yeah.
So that's good. I'll have to get more details from you. And as a note, we are playing with this at Netflix, and we have seen probably about the same amount of additional retransmission that you have, just a very small amount. One thing I have noticed is I'm actually able to detect all false retransmissions completely, whereas you can't with normal stack TCP. You don't know, at least with the BSD stack, I can know when I do a false retransmit because of a timeout, but I don't know that with a SAC, but I will detect it with RAG.
Oh, interesting. Yeah, I should probably ask more detail. I never thought about that. Yeah.
Last second, one very quick clarification was when you said 0.5%, is that 0.5% more bandwidth overall used, or 0.5% more retransmissions compared to the old?
No, I just compared the total number of retransmissions on this two set of group. Yeah.
Okay, great.
Yeah. Next slide, please. So the status is that we have deployed at Google for 3 years, and then the first cut is upstream to Linux. And we're planning to upstream the recent sort of timer enhancement to Linux very soon too. And as far as I know, there are, as Brendan mentioned, they're working on a BSD implementation. And I believe Praveen is also working on a Microsoft implementation, which is great. So I'm here to ask the question, is there any interest to make it a working group item since we have seen some positive results?
Praveen Balasubramanian, Microsoft. Yes, I think this is very good work. As you said, we have implemented this in Windows, and I think this would be a very good item for the working group to publish as an experimental RFC.
Thank you.
I would agree with that statement as well from Netflix. Randall Stewart.
Live second. Yeah, so it sounds we should do this. I would like to see more data at some point, especially as other people play with this, right? Because it's, this is TCP and this is a pretty core mechanism that we're changing here. But what you've shown looks very promising, and I think we definitely want to work on this. But if people have more data, if you have more data, or anybody, right, come and share it here or in ICCRG. Yeah.
But if it's experimental as target, then we can collect the data along the way.
Well, Christian Wiedemann from Microsoft. I'm working with Praveen on this. But basically, people realize that what is proposed here is to do away with the DUPAC strategy and just use RAC instead, right? And I do think it's a good idea, but I mean, let's not be surprised. Okay. Yeah.
Yes, the intention is to replace the DUPAC strategy or any counting-based approach.
Ingemar Johansson. I'm quite interested in this, and I spent a couple of weeks at least trying to understand the Linux TCP stack, Voodoo Magic, when I was implementing in our LTE system simulator, this a TCP stack model. And I find this much more easy to understand than all the special tricks that is done in the Linux stack. But given that, and we have done some studies on 3D stacks today. They ensure in sequence delivery because we generally use RLC acknowledgement modes, and we want to keep a packet ordering. And we did some studies and tried to see what kind of drawback do we get when we sort of skip the in sequence delivery, and we get a slight degradation. And also, given that we need to sort of cope with the legacy stacks for a foreseeable time, currently we can't skip in sequence delivery, at least as I see it. So, but in the future, if we can skip in sequence delivery, you can simplify the stacks quite a lot, and you can save some extra implementation hours for our engineers, actually.
Yeah, so I think let me I think there are two questions here. One is there any caveat or limitation of this approach? So one limitation I'm finding today is that in say data center transfer at very high speed, and then let's say you reordering the packet to hell, right? Completely randomized, permutate. In this case, in the current Linux approach, it actually set the DUPAC threshold to something reasonably high, basically match the congestion window. That basically means that you will almost never retransmit. And if in fact there is pure reordering but no loss, in this case, actually the current DUPAC threshold wins by claiming you can never retransmit. And in RAC, if you set a reordering timer to be, say, pick a number, a quarter RTT, a half of RTT, then you will have spurious retransmission. Then you have to rely on the current TCP undo mechanism to sort of fix that for you. But unfortunately, since you still go through this retransmit and undo, overall, at the very high speed, RAC still loses slightly. Yeah. So that's the limitation, and I'd like to put that in the next draft as well.
Corey Fairhurst, very quick. What you just said is interesting to me. I'm interested that TCP is robust, and one of the ways we've made TCP robust to very varying paths is because the stuff happens on path and it's in order, and the DUPACs come round in order. As soon as we have a timer-based mechanism, we have a little bit more question about how robust it's going to be. So can we just make sure we look at this? I don't see this as a stumbling block to going ahead, but let's make sure that we continue to operate whatever happens on the path.
Okay, I think the best way is you can come up some example, and I can try to do a packet drill test on this, implementation. Yeah.
Yeah, sure. But they're going to be weird ones because we want TCP to work in weird situations as well as common ones.
The more weird, the better, because however weird, I can see some example on the internet anyways. Yeah.
Last second, one thing we should do when we do this is I would like to see some good guidance on what this reordering window should be. You said pick a number a couple of times, right? And we've picked 3 for the 2-back threshold, right? And it's questionable whether that's the right number, but at least it's a number that works reasonably well everywhere. So I would hope that we can give some guidance about what people should be using as a reordering window. And yeah, they can play around longer or shorter variables, but at least have, one scheme that we recommend in the draft and says, if you do the experiment with this, maybe you want to start by using this reordering window.
Yeah, so this is, yes, I agree. There should be some clear guidance, and the value is probably going to be empirically determined. I plan to run a more experiment on this reordering window, but based on my current experiment, setting it to half RTT or core RTT doesn't really matter that much. It's a little bit like the RTO. Setting it to 1 second or 1.2 seconds is not going to give you a vast difference. Yeah.
Jana Iyengar, I just want to draw attention to one thing here, and I think this is perhaps to me the most interesting thing about RAC, is that it fundamentally changes the way we think about loss recovery, as we have thought about loss recovery, changes it from sequence number space and moves it into time. And I think that's a fundamental shift, and it has the power to simplify pretty much everything we've done in the past 25 years in loss recovery. And that's very powerful. And to the extent that we want to discuss how we can figure out how long to wait and so on and so forth, those are things that experiments can yield results for. The reordering window, Lars just pointed out that we have 3 as a number. And that's true. While that's true, Linux still has the reordering threshold, which keeps getting bumped up as it sees spurious retransmissions. It's a very discrete value where the number of dupacks keeps getting increased. But here you have a much more continuous value, which is the reordering window. So you can actually tweak that based on if you see spurious retransmissions, you could increase the reordering window and make it more adaptive. So there's certainly much more work that can be done on the basis of this framework. But I think the framework itself is extremely powerful, and we should consider that when we talk about whether we should take this on.
Praveen Balasubramanian, 2 questions. So one thing I didn't notice in the draft was, do we ever discard the value of min RTT, and should we discard the value after retransmission timeout? Then RAC basically fails to do a loss recovery. And the second question is, you mentioned some cases where due to load balancing, packets of a single flow can appear out of order. That seems like a bug in the implementation, because usually even with ECMP or NIC load balancing, you would hash the flow to make sure that it's always processed in sequence.
Yeah, so I think for the first question is the min RTT. So in our own implementation, we don't discard the min RTT sample after timeout, because the min RTT sample we take is the whatever RTT that we believe is the correct RTT sample, but there is no ambiguity in it. So we don't, either we have a timeout or not, it doesn't really affect that measurement.
But the min RTT is over the lifetime of the connection, right?
The min RTT, in our own implementation, we actually use a window min filter. So it's not over the lifetime of the connection. It's like over the last 5 minutes. Yeah.
I think that should be in the draft.
Okay.
The second question was about the reordering.
Yes. So the reordering, yes, I think with ECMP, or if the design, the network devices are designed correctly and functioning properly, yeah, there shouldn't be this kind of packet being bounced on 2 paths. But in reality, we actually found that out that on like a few load balancer case. And when we contact, for example, one of our internal load balancer has this issue. When we contact him, they just say, well, based on variety of reasons, we're trying to keep all the flow on one path, but sometimes we just have to put them in a different, execution path, and that will result in reordering under extreme load. Yeah.
Christian I just want to reinforce what Lars and to particularly Jana have been saying. I mean, the reordering window is a key parameter there. And so if we have a draft and if we really want to have it replace, I mean, the existing mechanism, then we should have some very thoughtful guidance for how do you do that initially? Because, I mean, just putting, say, half the last min RTT or something like that is just a heuristic. And we have to be a bit smarter than that, I'm sure.
I see. So you said there should be a clear guidance on the reordering window adaptation algorithm.
Yes.
I see. I agree. Yeah. But right now I don't have one. So.
Yeah, but I mean that's basically, if we make that a working group item, then that should be something the working group is working on.
Yeah. Based on my sort of observation on the traces, it's very hard to come up something a perfect sort of reordering window, because it's somewhat, if you look at sort of the AL2.11 reordering case.
And we are cutting the lines afterwards.
Okay, the reordering window, the packet are getting reordered in sort of basically within sort of an RTT, but it's hard to say, all right, for this reordering, it should be a quarter RTT, or for the next reordering, it should be something.
Take the example of the load balancing between two paths.
Yeah.
The reordering will be the difference in delay between the two paths.
Yes.
And it's only vaguely related to the RTT. It's
yes. Yeah.
So basically, we need. My point is, we need to make that a point that is studied, and for which there is a default algorithm.
I see. Okay.
Randall Stewart again. I've actually thought about making the reordering window adaptive. So as you start recognizing that you're retransmitting falsely, you start bumping up the reordering window. It has an alternative to, just having a fixed set window.
Yes, I indeed tried that, and I didn't see much difference in the result. That's why I kind of skeptical of my own approach. Yeah, too. But that's definitely worth in-depth discussion on the draft.
Okay, so this is Michael speaking as chair. So you have two questions here on that slide here. I will start with the second one. So what's the relation to TLP?
So it doesn't really changes how TLP works, and it just works with TLP naturally. You can implement the two, and you don't have to do anything special about it. Yeah.
So, but you mentioned here on the slide that you might want to merge it into one document, or do you plan to keep this as two documents, or what's the plan here?
For me, as a TCP developer, I personally like to see one RC that covers the loss recovery instead of 5, right? Or 2, or even 2. Yeah. So it's fine if they are. I think you are saying if they are completely orthogonal, why do we have to merge? I think that's just for the convenience of developers implementing a better algorithm. Yeah.
Okay, then let's have a look at the first question. So I will ask a couple of questions to the room because there seems to be interest here. So the first question that I'd like to ask is, how many have read this document? So this is more than 10, I would say. The thing is, we can do different things here. We can adapt the document right now, or we can wait, for example, for an update of the document that includes TLP. So that's why I'm trying to figure out what the preferred way of the working group would be here. So first of all, maybe the very general question, could I please have a show of hands if you generally believe that REC should become a working group item with details to be sorted out? So this is more than 20, half of the room at least. So this is pretty strong support. Is there anyone in the room who does have concerns with adopting something in that space as a working group item? So I don't see any hand here. So it seems that, which is in line what we've heard before, that there's a relatively strong consensus that we should do something here. And now regarding the specifics. So the two options that I can see is that we either take the document version 01 as a starting point and immediately make this a working group item. Or the other alternative is that we wait for an update, for example, with the change that is here on the slide, and then adapt this. And I'm wondering if there are any preferences. So I will offer both opportunities to the working group, all right, not just to see a little bit what the preferences are. So if you think that we should immediately adapt the document as it's written right now, it has been presented here as a working group item. Obviously, the working group item means that the work can evolve, for sure. But if you think that should immediately be adapted, then please give me a show of hands. So this is of the order of 10, slightly more than 10. And are there any people that think that, for example, we should first have to figure out how TLP fits into this, so that there would be a reason to maybe wait one version and then adapt it? Are there any people that would prefer that option?
I did not have any particular difficulty implementing TLP in conjunction with RAC, and I don't see any problem there.
Okay.
However, I do think that TLP does stand it on its own merit, decoupled from the actual loss recovery algorithm. So it's a tough choice, but yeah, it's up. I would probably leave it up to the entire. It's like consensus probably.
Since the Andrew McGregor, since the features are largely orthogonal, does it not make sense to decide that basically on the document author's opinions?
Yes.
So what was this? So what was the comment? Sorry, I didn't hear it.
Basically, rather than do whatever is convenient for the authors of respective drafts, because they seem to be largely orthogonal, even though they do
Okay.
relate to loss recovery.
Okay.
I think
Yeah.
so we are looking at experimental RFC. I think that's I guess the thinking in the room, if I understood right.
Okay, it's working.
Does this need to list the RFCs that it's going to update, or in the TCP roadmap document, perhaps? Where is the list of the mechanisms that do not need to be implemented if you implement that?
Well,
That has relevant person. But on this one, I was just updating by doing an experiment.
Yeah.
So you need to document that. You probably just want to start an experiment. Yes. You might take it.
Yeah, I
Might not work.
I totally agree. So if we do an experiment, we don't have to update those things. Obviously, we can state in the document that this is an alternative to a number of RFCs. So this can obviously be stated as part of the experiment, but formally we don't update those RFCs out of my head. And what I'm hearing here is we are not heading to propose standard right now, because there seem to things to experiment on the reordering window and things like that. Okay, then it looks to me that there is a strong support in the room for adapting the document. We will confirm this on the mailing list, and then we will work with the authors on the details how to do it with TLP. But here in the room, the consensus is very clear.
Thank you.
Okay, then we are slightly late on time, but we move on with Praveen.
Hello, everyone. Praveen Balasubramanian from Microsoft. Today, I'm going to talk about transport's advancements in the Windows network stack. This is primarily work that we have done for the past year, both on the client and the server operating system. This talk is different in the sense that I'm not presenting any drafts here. It's mainly intended as evangelism of the work. talk about some of the APIs, also show that the work that's happening in the IETF is having an impact on real products. I have also some questions that I would like this room to debate about. So that's the purpose of the talk. So to start with, I want to set some context. So there is this ossification problem, protocol ossification problem that is brought up again and again at IETF. The key barriers today to innovating on TCP are primarily three. The first one is you have a variety and multitude of client operating systems and devices that don't normally always get upgraded to the latest kernel version. Most of these protocols are implemented in the kernel, so if you can't update the devices, then you can't have new features. The second one is a well-known problem, middle boxes. They don't like new TCP options. They sometimes drop them. They sometimes black hole all the traffic. All these problems have been documented again and again. And the third one is obviously on the service side, the same problem with kernel updates and adopting new features.
No.
So this is kind of my position. I'm not speaking for the company, but
Where can you do it?
to address problem one, we need to have continuous OS updates. Now, this is not going to solve the problem completely, but if you have majority of the devices moving to the latest operating system, then you have some adoption of the new features. To solve the middle box problem, you enable these features, but you have safe fallback so that the user experience is not harmed. And then you have fast moving services which adopt these features on the server side, and then this would spur more competition and other services would adopt the features as well. To solve problem one, this is more of where the business is going. So Windows 10 is the most recent client operating system. It's now on 350 million plus devices. The trend for both Windows as well as other mobile operating systems is the notion of continuous updates. So the argument that the kernels are no longer getting updated very fast does not hold. Windows 10 is also across device types, so it's not just a desktop PC operating system. We also see that enterprises are piloting this right now, so we hope that the numbers will go up further. For the past year, we've been working on the anniversary update for Windows 10. It's supposed to release soon, and it'll be a free update to all the existing Windows 10 users. So whatever enhancements I'm going to talk about today will reach a large subset of these users shortly. Similarly, on the server side, Windows Server 2016 is again slated for release this year. This powers two of the largest clouds in operation at the moment. So again, server-side innovation is going out there and it's getting updated very fast. The work that's done here was in conjunction with several people across several teams at Microsoft. I'm speaking on their behalf. Can we go to the next slide? I'm going to start by saying that there has been a lot of work in TCP innovation over the past few years. So when we started this project, we essentially looked at what would give us the maximum gains in the least time. So we looked at the existing data that other companies have published. We ran our own experiments and decided to pick the best of them that we could implement. So I would like to start with TCP Fast Open. So both in the anniversary update for Windows 10 as well as Server 2016, TCP Fast Open is a feature that will ship. Fast Open allows you to have one RTT handshake for TCP, which is a step on the way to zero RTT. So here I have a diagram. I think most of you might be familiar with this already. So for the very first connection to a server that supports Fast Open, you have the TCP SYN go out with the cookie request. The server responds with a cookie. And then the usual SSL handshake proceeds. But with Fast Open, if you notice, Fast Open is not specifically tied to TLS, but it's most impactful when there is a TLS connection. So here we have a TLS false start, where the very first packet includes the client hello, and the server responds with the server hello. So we basically cut down like one RTT. Can we go to the next slide, please? So yes, we as a company are very interested in TLS 1.3, which is currently being worked on at the IETF. The implementation that we have today in Windows that's going to ship shortly is RFC 7413 compliant. The TCP global setting that enables Fast Open is enabled by default. There is a setting in the Edge browser which allows you to turn this on for all outbound connections. When I say all, there are some caveats, like it doesn't work when you have a proxy, and there are certain other cases where we automatically turn it off. But for the most part, if you enable this setting, every outbound TCP connection will try to attempt fast open. There has been some issues with fast open that have been brought up at the IETF before, most notably in talks by Apple. So we found very similar issues, but I would like to bring up that we found one more class of issues that I don't think is very specific to Windows, but because there is a high prevalence of antivirus and firewall software on Windows, we found that there were both problems with third-party software as well as the operating system. Third-party software assumed that, for example, the SYN packet would not have data. These are software that have been written 10 years ago. They don't get maintained, updated very often. So we are working with them to address these issues. Do you have a question?
Yes. Sorry, Mike is still growing. Yeah.
David Skenazy, Apple. Just a clarifying question. When you say on all outbound, you mean all the ones that use TLS, right? Because you can't just use it on all TCP.
Yes, correct. Only TLS. So
Awesome, thanks.
yeah, that's one of the caveats. So no proxy, TLS, and there's a bunch of other conditions where we. I don't have the list of conditions right now, but I would be happy to send that offline if anybody has questions on that. So apart from firewalls and antivirus software, obviously we found problems with middle boxes because we sent this out as a preview release to a bunch of insiders who kind of use a beta version of Windows. And the class of issues is what Apple documented earlier at IETF. We find that this requires both detection and mitigation for each of these class of problems. Now, TCP fast open is unique that there is not just a new TCP option, but there is also change in the way a packet is sent. For example, the SYN packet has data. So the request to Tcpm community is that we should standardize on these detection and mitigation algorithms. I would be happy to work with someone who would like to take this up. Yeah, please. Next slide, please. Some more details here. The implementation does use the IANA assigned option number 34. One of the implementation experience was that we found it very easy to model this as a state machine. So if you look at TCP today, there's a big state machine where TCP moves from a SYN sent to established and so forth. We found modeling TCP fast open as a state machine very easy to implement. It allowed us to also have telemetry data about the connection become very intuitive. Again, I would be happy to explain all the different states that we use for the client and server side offline. One thing we found that because the setting enables fast open for pretty much any connection and doesn't really restrict it to particular servers that we know support fast open, means that we were worried about the SYNs timing out. There's a problem with SYNs timing out today because at least in the Windows implementation, when the SYN times out twice, we turn off the window scaling option. So that has performance implications. So if TFO caused the first SYN to be always dropped, then it could have serious problems because if you drop the second one due to congestion, then you run into this problem where window scaling gets turned off for the connection. So, but we did an analysis with the top 10,000 websites and we don't really see a strong correlation between SYN getting dropped. So the servers that don't support TCP fast open are pretty much responding with no cookie and the connection proceeds normally. Yeah.
You have to go to them.
Your words where you can see a strong correlation, that says no correlation.
Not statistically significant. Like I don't even have like good examples where this was happening consistently. Because there could be SYN drops due to congestion, so you can't have a perfect experiment. So the second sentence is probably not, sorry, this sentence is not worded very well, but the servers that do support fast open are only supporting it on 443. So most servers are not supporting this for non-TLS connections. The client side will accept cookies of all valid sizes as specified in the RFC, not just 8 bytes, which is what I think the Google server responds with today. The server side support is still in beta, it's not complete. Now I want to talk a little bit about sample code. I think this question also came from Yuchung earlier. So the way you enable fast open is that there's a new TCP option called TCP_fast open. You basically set it to 1 on a socket before you connect. Interestingly, we already had an API called connectx, which allowed you to specify data when you do a connect operation. So the way this is documented today is that you specify a buffer, and the buffer is basically sent after the connection is established. I don't think this was pre-signed. I don't think they knew about that TCP fast open would be invented, but we had the luxury of an existing API. So we will change the documentation to reflect that. If you set the option, then part of the data that can fit in the SYN is sent immediately, and the rest of the data is buffered. And after the SYN arrives, we send the rest of the data. The same socket option can be used to verify whether fast open actually succeeded. Some of the apps are interested in this, so for their own statistical reasons, telemetry. So you can actually find out whether it succeeded or not using a get socket option API. Any other questions about fast open?
Jana Iyengar, I absolutely love the fact that you guys are experimenting with this. Is that the link to the current API that exposes fast open? Okay, that's awesome. I mean, we should talk offline because I implemented use of fast open in Chrome, and I would love to be able to use it with the Windows API as well. And I would ask that the API expose error information that's specific to fast open so that we can log them and figure out what kinds of network anomalies we see. I don't know how much ability you have into logging and seeing those things. But if we have the ability to pull that out of the API, we'll be able to record that.
Good suggestion. Right now, the only error information is basically a single bit, which tells you whether fast open succeeded or not. But we could certainly look into making that more detailed. This is long coming. This is a very old RFC draft, which proposes that the initial congestion window of a connection be increased to 10 MSS. Up until Windows 10, like the one that's in the market right now, and the Server 2012 R2, which was the previous server release, the initial congestion window was 4 MSS, which was a very conservative value. The new operating systems that I talked about are going to have the default of 10 MSS for all connections out of the box, for all connections. We do have mitigation that if we detect that the very first burst incurs a loss, then the initial congestion window for that connection is rolled back to 4 MSS. The initial data we have does show an increase in initial burst. I can't share the exact numbers because I don't have permission right now, but we are working on quantifying this increase. We are also working on A/B testing with initial window of 4 and 10 on a single device to see whether we can have better mitigations here. There is also an API which works on both client and server. It's basically a WinSock ioctl that you can set. On client, we limit it to up to 10 MSS. Actually, there's 3 values. And on server, you can go all the way up to like 64 MSS. We'll go to the next slide.
Strange procedure to ask a question at the front. I wonder, have you thought about caching the failure of the bus to get through and then clamping IW to 4? Because I don't understand what IW4 means when you're going to try to get at 10 next session.
That's an interesting suggestion, and we have been looking into sharing information across TCBs for this. Again, you could be too conservative there, and if it was just a series of burst losses, you could end up, for example, on a Wi-Fi network, turning it off for a long time. So we are working on a good algorithm and heuristic to make this more effective. Tail loss probe. This is also on by default and in both the client and server operating systems. The goal is to convert RTOs to fast retransmits. The draft talks about allowing both a single probe or two probes. In our implementation, we hard-coded to a single probe. I think the draft also says that it uses the term should and says it should be a single probe and be limited to only one. We do find from data that the parameter WC del ACT, which is kind of the assumption on the sender for what the receiver's delayed ACT timeout is too conservative for the case where there's a single outstanding segment. Because the total timeout in our experiments for connections that have high latency turns out to be the timeout exceeds the min RTO. So I had a couple of questions for people who work with the Linux kernel. What value does the Linux kernel use today? And does the kernel have dynamic ACT timeout tuning?
Linux for many years has been using 40 milliseconds, but and it doesn't do any dynamic delayed timeout tuning, but it does try to tell if the connection is a request response or a bulk connection, and it's and tune the presence of delayed acts at all accordingly.
Thank you for that information.
What does Windows do these days for the delayed act?
Windows, starting with Windows 8, does a dynamic delayed ACT based on RTT. I think this is another item that would be useful to standardize as a draft, the delayed ACT timeout tuning. Talos probe is also on by default for both the client and server operating system. One of the restrictions, though, is that we only enable this if the connection has more than 10 milliseconds RTT. Because we find that most servers have a timer granularity of 15.6 milliseconds by default, and changing that to 1 millisecond has power and performance implications. So timeouts finer than 10 milliseconds are usually a problem for efficiency reasons. We also have implemented FAC with a threshold of 3. This directly helps both TLP and rack that I'm going to talk about in the next slide. Recent acknowledgement. This was a draft that was presented in the last IETF by Yucheng. So we have implementation of this again on both the client and server operating systems. One of the implementation choices that we made was to use a rotating buffer of time slots. So we don't really track the time for each send because of the memory overhead. There's a trade-off here between precision and memory space. So if you have fewer time slots, then you're going to classify more sends into the same slot, even though they might have been off by a few milliseconds. They might have been sent at different times, but you would classify them as in a single time slot. Again, we just need 2 indexes to deal with this data structure. One is the reading index, which tracks with the acts, and the insertion index tracks the new sends, and then everything in between can be used for a loss recovery episode. All of the LSO or the TSO in Linux sends are tracked in a single slot. It is not expensive in the Windows implementation to convert LSO to a standard send during loss recovery. So this is not really a big problem in our implementation. Again, this is on by default. And again, we restrict rack to connections that have at least 10 millisecond initial RTT. So this is again, initial RTT in the SYN handshake. We use a reordering window of min RTT by 4. Again, this is one of the reasons why we do not want to enable this for example, data center connections. We do notice an increase in spurious RTOs with rack enabled. Again, I don't have specific numbers to share today, but we are investigating further, and I will take it offline with Yucheng. But some of it is expected because this is certainly a more aggressive algorithm, if you will, compared to the traditional loss recovery scheme. But we are investigating this further. Yeah, this was basically our point of view when Yucheng presented the new update, that we would encourage Tcpm to publish this because it has seen wide adoption at this point, and I think it would be worth publishing it as experimental.
Briscoe, just to make an observation that the goal of RAC stated earlier of being a universal replacement seems that you've got some exceptions here that would be nice to know why those exceptions exist and what makes it not be universal, like the sub 10 millisecond.
Right, because then, yeah, but because then your reordering window becomes 2.5 milliseconds. And as I said, there's a performance overhead of reducing the clock, increasing clock frequency of a server or client machine. Can you go back? LSO is basically TSO, large send offload. So it's basically sending one large packet to the NIC to segment it. I think we can go to the next. We noticed this trend of a background downloads problem. This is kind of getting exacerbated now because of the first slide where I said operating system updates are becoming more and more prevalent. We have also today networks that are extremely congested. For example, your airplane Wi-Fi. So if a background download starts in a plane Wi-Fi, when you're in an airplane, then it basically kind of congests the entire network, affecting even other users. At least we have some data showing that. So we implemented essentially, initially started out with RFC 6817, but in our experience, it did not really perform that well. Now, so as a result of that, we made certain deviations from the RFC, which are at the moment I am not at liberty to talk about, but I will try to talk about them at the next IETF. At the moment, this is an undocumented socket option. It's not really available for everybody to use. We are working with first-party workloads, including Windows Update, to kind of do trials on this. As I said, yeah, more on this in the next IETF. This is kind of the last slide, and it's probably the most controversial. So today there's a diversity of, oh, sorry.
A short question around LEDBAT here, and I assume that you need to infer the timestamp clock on the opposite side, or?
That is a well-known problem with LEDBAT, yes.
Yeah.
And Windows does not use timestamps by
I know.
default. So, sorry.
Okay, and that's one problem that I saw also with LEDBAT on the. And another one is that regards to the problems. I don't know if I got a troll or something in my sort of a simulator setup, and I always needed to set the initial congestion window to 4 segments in order to get it running. 3 or lower it when it was stuck at a really low congestion windows. So could be also some issue with LEDBAT or in my simulator.
Really quick. Yeah. So there's a diversity of congestion control today. Windows client uses compound TCP. This has been the case since Windows 7. Server picks dynamically. If it's a low RTT connection, it picks data center TCP, which is not effective if you don't have ECN marks. It becomes new Reno. And on high latency connection, it picks again compound TCP. Linux kernel has Cubic as the default. We are evaluating a prototype. It's not in the product code that's shipping. This is a diagram that I kind of stole from a paper, TCP Ex Machina. This was work done in MIT by Keith Weinstein. Last week in a Microsoft Research Faculty Summit, he presented this talk about how today's congestion control algorithms are not really performing very well on LTE networks, especially in countries like Africa. This is throughput versus queuing delay measurement, essentially on Verizon's downlink network. I think this is 4 flows of a given type contending with each other. I don't want to talk about REMI. It's basically in the paper. If you're interested, it's basically a computer-generated algorithm for congestion control. What I want to focus on is the fact that there's a spread already with the existing congestion control algorithms. This is not my data, but it seems like Cubic optimizes for throughput and does introduce more queuing in the network. So the question here is twofold. Does the community see value in standardizing to a single congestion control algorithm? If yes, why? If no, why? And the second question is, should congestion control algorithms optimize for throughput, or should work towards minimizing the queuing delay problem, the buffer bloat problem?
Right.
As I said, this is controversial. So.
I got there first.
Please, I mean, we are late on the agenda, and this is a very generic question that is at least partly outside TCPM scope. So
I'll be quick.
As you can make maybe two sentences each of you, and then we will cut the line on this specific question.
Okay, Bob Briscoe, the interesting thing about this is that it doesn't think of changing the feedback mechanism, and the machine-generated algorithm even didn't think of doing that. It was just scope to change the algorithm, not the protocol. And when you change the protocol as well, you have possibly more scope, like DC-TCP isn't on there, for having high throughput and low delay.
The problem there is that today you really can't experiment with DC-TCP because of lack of support in the switches. So that's one of the reasons it's not here.
Last second, I don't think there's a. So we had standardized on one, right, which is new Reno, and then Linux went and did Cubic, and it seems to work okay, right, which has sort of shown that there can be many, and it's not a problem, and I don't see buy-in from everybody to do just one algorithm, right? You guys are doing several for several scenarios, and that seems to be fine. What was your second question?
The second question is a throughput versus queuing delay.
Yeah.
So should we leave it to the network operators to fix the queuing delay problem, or should it be on the congestion control algorithms running in the end devices to not? Because there's also a perception problem here that if everybody implements a very aggressive congestion control algorithm, sometimes even probably violating the RFC, then we are not really incentivizing people to solve the buffer bloat problem.
Yeah, so that's a longer discussion that we're not going to have here, right? But I think sort of we can't solve this at the congestion control level alone if everything remains FIFO, I think.
As regards to the throughput versus Ingmar Johansson, throughput versus queuing delay, I believe that they probably discussed in the ISSGRG session. And but one comment about all of when it comes to the mentioned Cubic or New Reno or whatever, it's a loss-based congestion control in and then LTE context. It's important to know that most LTE networks are AQMLS. They are sort of a buffer bloated. So it means that you don't have a Cubic, you have a slow start. And with some exit condition, and Reno, you have only a slow start and a limited congestion window by a sort of a receive window or something like that.
Okay, at least they're
not loss-based anymore. So.
Well, at least their experiments show that there's a very large queue that gets built up.
Yeah, you will get a very large queue in order of seconds or something like that if you have a poor coverage. So.
Dave, Todd, just 2 sentences. Dividing up the question into just those 2 questions actually really requires more beer.
We probably need a barb off or something.
So I would enjoy actually pursuing that set of questions later. Also, you said that Microsoft Research just published something on REMI?
This is not Microsoft Research. This is research out of MIT.
Well, okay, so there was a follow-up recently from Microsoft Research?
No, there was a faculty presentation about this particular set of observations.
Okay, so this is Michael speaking. We are relatively late on the agenda. And I'm not just, first of all, this here is, in my opinion, closely related to ISSGRG. So the discussion on this slide here, in my opinion, does not belong to TCPM as of now. However, there have been a couple of other topics in this talk that actually are related to TCPM. And I specifically wonder about one specific thing on the fast open, for example. So because some of the things that were mentioned here could end up in an update of that RFC. So there was an errata on the slide, but we could also update the RFC. And even thinking further, we could move it to standards track under certain conditions because it's experimental right now. So one thing the working group could think about is whether it's worth to update it, and if it's worth to think about the status of an update. So I'm not making any statement here, but I think it could be something we could discuss in future.
Last thing, I wanted to thank Praveen and Yusha because I think I know it's hard to be able to talk about these things and getting clearance, but these are the most important talks we have, right? Because people come back with implementation experience and they talk about it and they want to make stuff better. So thanks for lining these up.
Okay, we have to move on. We are late on the agenda, so I will ask the following speakers to be short so that we can at least complete the schedule. Thanks. The next one is Naeem with Ape.
Okay, so I will try to make it as short as possible. So today I'm talking about the new draft that we are having. Is called the TCPM Alternative Backoff ECN. Next slide, please. So basically some backgrounds. What we are trying to do here is to let the TCP sender to basically react differently to ECN marks compared to the reaction to the loss. So the reason behind that is that when we have a ECN mark, we already know that there is perhaps a shallow buffer or a mimic of a shallow buffer somewhere on the bottleneck, which is basically done by the AQM. And therefore, we don't need to react as aggressively as we do with loss, which is going down by half. So we could have a different reaction behavior. And that leads to having a better utilization with the negligible impact on the delay. So right now, what is happening is that the RFC 3168 and RFC 4774, there are texts in there that prohibits this, and that doesn't allow us to do experimentation. We have proposed an update to that in the draft in the TSVWG. It's called the ECN response, and that's gonna remove that limitation there, so that we could now do the experimentation. And then we have proposed a beta value or the reduction value in the draft that we are discussing right now here. And that is called the TCPM Alternative Backoff ECN. Next slide, please. So there's basically a timeline of what we've been doing. This is started in IETF 93 with the draft Khademi Alternative Backoff ECN. We showed some simulation and experimental results that basically promising a better utilization with the negligible impact on the delay, and therefore we could basically have a better reaction to the ECM marks that is different than loss. And then we got feedback from the TCPM chairs back then that this should be discussed in the ICCRG. We discussed that in the ICCRG, and then we proposed an update 01, which we presented in IETF 94. And then in that update, we provided some clarifications in the language about the scope of this draft and where it's useful. It's on the access links. It's where you have a low multiplexing and where it's practical. And then we also addressed the comments that we have on the mailing list of TCPM and ICCRG back then. Then the last IETF, we basically provided another update to TSVWG. And we made some fixes up to that update. That was to use the flight size instead of the congestion window in the terminology. And then we went to area directors, and based on their recommendations, they decided that actually the initial draft basically was basically proposing an update to 3168 and also recommending a beta value. We separated this into two drafts. The first one, which is the ECN response, it goes into the TSVWG and it updates 3168 and 4774. And then the one that we're taking to TCPM is basically to basically support, to propose a concrete backoff behavior here as an experimental RFC. Next slide, please. So that's basically this. So the first one is basically relaxes the ECN mark reaction to be different than with loss, that is in TSVWG. And the second one, which is here, it recommends And that experimental deployment basically uses the flights that they multiply the flight size by 0.8, and then they reduce the slow start threshold accordingly in the congestion avoidance phase in response to the ECN eco flag. And where we take this 0.8 from is we did a technical report that has been there for a while, and we used the results of that technical report to come up with the choice of a multiplier. And the next slide, please, which is my last slide, is that I have a question to the working group. Should TSVWG basically adopts the other draft, which is the ECN response, is the TCPM interested into adopting this draft as a working group item? It's basically a conditional question.
So before we address the formal questions, so are there any comments on the technical content?
Yeah, Bob Briscoe. I was thinking about this last night, actually, and I haven't put anything on the mailing list yet, so I'll try and describe it here. The Cubic is used as a justification for doing this, that it's already done in Cubic. Yeah? But Cubic only does that when it's got a high bandwidth delay product. And so, whereas this doesn't, it does it whatever the bandwidth delay product. So at the moment, Cubic up to, on say a 10 millisecond round trip, base round trip time, you have to get up to about 500 meg before you get the Cubic behavior, otherwise you get the Reno behavior. And so I wondered whether the friendliness with Reno stays there for the, yeah? And so I was thinking,
so we are late on the agenda, so
maybe I'll put it on the list.
We don't have time to reverse engineer the Linux kernel here or on the mic.
At least from our experience, this would be beneficial. A larger beta would be beneficial for only a few or single flows, right? And so if you have many flows sharing a bottleneck, then it's fine to use the default right now. So at least from our perspective, would be good to have something like an adaptive beta that corresponds to the current situation at bottleneck, but this is usually not possible without explicit or even more explicit feedback from bottleneck, right?
Sure, and then if you have many flows...
To the mic, please.
Okay, I was thinking I'm speaking loud enough. So if you have got many flows, as long as you've got the effective AQM that basically keeps the rate in a fixed rate, so you should be fine, even though you're using a a more aggressive beta. You're not going to blow up the AQM. I mean, because you get enough response from the AQM. So as long as you have so many flows, if your AQM is basically coping up with those number of flows.
Yeah. So what we found out is that basically you can keep the utilization high if the AQM is good in loss desynchronization.
Sure.
Hi, Colin Perkins. So I think this is a reasonable thing to do, and I would support it going ahead in this group. I think there's an issue which will come up with the alternate response for ECN, is that it's not just TCP which interacts with ECN, and all the earlier bits of this work were only updating the TCP related ECN drafts, and there's a lot of other work going on in IETF which does ECN with non-TCP stuff. So you need to make sure that when you have that discussion in TSV, you take that into account. But as a way of updating TCP for ECN, this seems reasonable.
David Black, TSVWG chair, and I'm going to be probably the person responsible for the TSVWG draft. Colin set me up nicely. What we're going to say is that the TSVWG draft, this is going to be probably treated as mostly a process draft. It doesn't actually do anything. It just removes some language that prohibits experiments. And that's roughly how I anticipate treating it in TSVWG, namely that we're going to talk about this as removing this prohibition could be useful to encourage experimentation, and Colin's already indicated another domain in which some experimentation is appropriate and probably already underway.
Yeah, Because that was also kind of my clarification question. So it's always scary when you have things going in parallel in two working groups, but did I understand right that the other draft is mainly just a technicality to kind of remove this obstacle from the original RFC, and the main work is basically here, the technical work.
Yep.
That, yeah.
And a third yes from here, so we're all aligned.
Yeah. So there is no such problems.
Just just to comment that when we are evaluating the response, we should not just evaluate it in terms of how it interacts with TCP.
Yeah.
Yeah, Marco Goyo. I think it's just fine to experiment with this draft, but I know this comes from the ADs, the recommendation to have the other draft, but in its current form, it's very dangerous because it practically relaxes the requirement in 3186 for any use, not just for experimentation.
Well, that's basically a TSVWG discussion.
Yes, and I don't think that we need the other draft because we can do the experimentation. We can have an experimental draft which says that, or RFC that says that you can experiment, even though it's different from what some standard draft says. But in current form, the other draft, there is response draft. It's very dangerous because it relaxes the things for any use.
Okay. And what is your comment on this one?
This one is okay.
Okay.
Just explain.
David Black, TSVWG chair again. Let's make sure we get that discussion nailed to the floor in TSVWG. My sense is that we got to do some of the prohibition, but we need to leave IETF in control of the experiments. Opening it up so anybody can do anything they like. It has potential dangers. I would very much like to see us get that draft structured in a way, and we'll do TSVWG, where you're looking for IETF blessing on the experiments. In particular, you're not going to publish a spec that does something different without IESG approval.
Yep.
Okay, so I will ask a couple of questions. This is all tentatively because we are depending here on a decision in TSVWG, which we don't know right now. But let's assume for a second that the other document will be in some form move forward in TSVWG. Then this opens the room here in this working group. So first of all, I'd like to know, so how many have read this document, or let's say one of the earlier versions with the same technical contribution? So this is about 10, I would say. Okay, and then we will, I mean, we can't adopt the document right now anyway, because we have to sort out the formal things first, but I will do a hum under a conditional hum under the assumption that the formal things enable this. So if you think that TCPM should do an experiment with this here, then please hum now. But it's a hum. Okay. And if you have any concerns with experimenting this, that is, if you think that this should not be done or it should wait or whatever, then please hum now. So I think the sense in the room is there's a reasonable hum in favor of doing the experiment, and I've not heard anybody objecting to it. So we will discuss with the TSVWG chairs and the working group how to move this forward, but there seems to be consensus that there's interest in TCPM in experimenting with this. Okay, thanks. Next one is Michael. And please be fast.
So how fast it depends on questions. So this leave this up to you. Okay. Hello, this is updating 2140, which is a pretty old document on control block sharing. Yeah, next slide, please. It was a proposal at the time it was written. Things have changed. So the one major change here is that this is talking about past tense and documenting what is being deployed out there and making some recommendations. TCP sharing in some form is now widely deployed. Certain things of it are, certain things are not. It's useful to update this, and well, this is what we think. So there was a previous document. This is just replaced. So that was just giving an overview of current deployments. Yeah. Next, please. As I said, updating to present tense. We cite a few more up-to-date things. We talk about initial window recommendations related to the congestion manager. There was some that, I mean, if you look at 2140 today, it's a bit confusing in that it doesn't very explicitly say, or it does it, but it's not very, very clear and very obvious to see that this is really only about the initialization phase and about when the flow terminates, and not about ongoing connections, which is being addressed by a congestion manager and some other work. So this is not being cited and clarified. Patent U is added to a list of cached values. There is some talk about as a thresh. There are certain equations in use on how this is currently being shared, for instance, in FreeBSD. Yeah, and there is also some text about caveats. So the previous document didn't talk at all about what would happen if connections would not share the same bottleneck in the network, and that you can sometimes have that, you can sometimes not have that. You may have an adverse effect of ECMP. You can use this much better when you, for instance, have packets, connections being tunneled in a VPN or something like that. So there is text addressing this. Next slide, please. Just an overview of deployment. Given the lack of time, I'd like to actually hop over this because this was presented before. So if you have questions, we can talk, but next one, please. There is some talk about caveats. So this is not very useful for connections that only send one initial window or less. And it's not useful for very long connections because it's only about initialization phase. So it has some use for connections that are in a certain sweet spot in length. It improves endpoint and network efficiency indirectly. There's talk about all these things on the update. Like I said, relating to how the impact that ECMP may have on it, and that you can use it when you're encapsulated, and there you expect this to work better. So it's just essentially about new text that is in the documents. It's quite a major update in terms of text improvements. Next slide, please. So questions here will be what the next steps are. Of course, we are requesting adoption. It's obviously a Tcpm document because it's only about TCP. It was individual and informational, and we authors believe that this is now appropriate as a best current practice because it really documents what's being done. Open tasks are specifying some capital may shoulds. It's unlikely that this would have any musts. It's describing things that are possible. That's my last slide, I think.
Jana Iyengar, this is interesting in that I'm curious to see, so going into a BCP, do we have any data to support what this has provided in terms of benefits? And do we have information about other implementations besides FreeBSD that have experimented with this and shown these to be useful? Because BCP to me is what we are recommending as the best current practice. I don't know that this is.
We have data from FreeBSD and Linux, we authors right now. So Linux wasn't listed much. That's because it's a no for being deployed. So much of this stuff is not shared in Linux.
Wait, is it? You said it's deployed in Linux. What's deployed in Linux?
There is, if you go back to the slide, there's one, at least as a thresh, I think. Yeah, as a thresh is being shared in Linux.
I see.
All the others are really FreeBSD only.
Got it.
They have code is a bit, for instance, congestion window is stored in a cache and never read in Linux. So it's not really used. It's some things you have to dig a little bit to figure out how it is. In terms of data, there is some data scattered in certain papers. For instance, there was a paper by the group of Anna Brunström and some others evaluating the impact of sharing as a thresh as it's done in Linux, I think for Linux. Pros and cons to it. So, I mean, there's some data about that. We can start digging up some data from various evaluations that exist, but it's maybe not a huge amount of data. Some practical experience with it exists. Yeah.
Praveen Balasubramanian. So we should probably also include Windows. And I think two things that we are sharing today, one of them is PathMTU. The other is the TCP fast open cookie. So I think both of those are interesting use cases.
Yu Chen from Google. I'm against the adoption of this because it's from a data point of view. Linux actually has this by default, but we have found out that the current implementation at least there's no benefit and often causes harm. I can give an example of caching SSResh. So one connection starts, experience some RTO, some losses, reduce SSResh to the minimum value of 2. The next one come up, it takes SSResh of 2, which could be 1,000 times smaller than the actual BDP. And from there, if you do AIMD, the connection goes nowhere. So,
right.
Yeah.
We know that, we agree with that. This is not a document saying you should do this, you should always cache and reuse SSResh. It says that this can be safe in certain conditions for certain things. It's about discussing pros and cons of sharing certain things under certain conditions.
But
it's
I'm
not
just
all
sharing the
useless
data.
always. If you're in a VPN, when you tunnel this stuff together, much of the sharing is pretty useful.
So basically, we have to look at the overall performance, and our experience is the overall performance of this cache is
that
not good.
from a VPN? Is that just from a web server? So it depends
It's
on
from
the
web
case.
servers
Yeah.
and data center environment.
My point is,
both.
it depends
Yeah.
on the case, and there's not a document saying you should always. Doesn't say
So
that.
this document becomes sometimes we should do it because it's good, and we're not quite sure about what sometimes means. Is that
in a VPN, for example? Always.
why would the particular problem be specific to? So the VPN can have the same issue. A connection starts.
No, a connection always takes the same path. So then you're doing the right
my
thing,
example,
right?
it takes the same path. The the first connection experienced a lot of loss because there was a lot of congestion. And then so he caches SSResh value of 2. And then after an hour, a new connection starts, which would exit slow start immediately. Yeah, right?
Which is a problem when the only thing you cache in this case is SSResh. If you reuse initial window, I mean, if you use.
So
you
what
reuse
I'm
the window
hearing is
version.
there is a lot of caveat in it. So at this form, I think you are simply saying, in some cases, caching will help, which I agree. In some cases, it does help.
Yeah.
But I'm just saying the current solution overall, I think it's, at least from a real user point of view, is actually cause more harm. And actually, Google has deployed our cache free-wide for many years. Yeah.
PathMTU has caused harm, RTT has caused harm.
I'm not saying everything, I'm just saying overall, this
But
matrix cache.
this is not saying do it all. It's having a discussion for every one of them.
Then I don't know
So-
what this document is going to say about it. It just say, okay, overall, this caching may have some benefit, and we should have a document
No,
for
it
it.
discusses the metrics individually. It doesn't say cache it all. It
So you're
depends.
saying, this document says, here are some of these things we can cache, and in
Yeah.
some cases, it
So
might
for
be
instance,
helpful.
okay, as an example, right, there is this work that I mentioned by the group of Anna Brunström that identified exactly the SSResh problem that you're talking about, and this document cites it and discusses it. It's not saying cache SSResh because it's always good.
So this
Right.
document is to document the pro and con of
For each, yeah.
each.
Yeah.
So it sounds like informational in that case, maybe.
Okay. Are you still against adoption? Just say if
I will hold my
the new scope
conclusion.
is
I'll
that-
read the document again. Yeah.
Okay.
Thank you.
Jana Iyengar, I have not read the new document, but based on the conversation, it's definitely interesting to hear that there are 3 operating systems that already do some sort of caching. This is not recommending caching. This is recommending best practices for caching. That's what the goal is, anyways, right? The plan is to say, hey, you guys are already doing this in some form or the other. And for example, what Yucheng said, that could play into being one of the recommendations.
could
that
be a
comes into the
recommendation that you
document.
don't generally.
Well, you could
share
say that
SSResh,
if you
right?
do cache as a stretch, then you cache it and you expire it in 5 minutes.
Yeah.
Or something like
Yeah,
that even.
yeah.
Those all could be recommendations.
Right.
The fact that it is being cached though is evidence that something should be said about how and why not things ought to be cached. Yeah, but I haven't read the documents, but it certainly seems like good to have people come out and talk about what the implementations are doing.
Yeah, so this is Michael speaking in this case as individual contributor. I agree that there's value in documenting implementation strategies. And a document on that would be highly valuable. I'm not sure if it's BCP in that case. One individual comment that I have is I think quite a bit of the current wording is inherited from the old RFC. And that is an old RFC. So looking from this, from the wording, what I read in the current version of the document in 2016, there could be opportunities to modernize the wording in many areas. And I don't think that you have to stick to the old individual RFC if you update it. So since it was an individual document, there's no need to do delta updates. You can basically write it from scratch.
But we did change a lot of things. I mean, if you could give us a more concrete list of things that you think are, I mean, you can have a conversation about what.
As I said, I mean, to me, I went through the document. It's not an easy read in 2016. And,
yeah, the old one is but I mean, we changed much. So.
Okay, as I said, I mean, we have to move forward. But as I said, I think a lot can be simplified and aligned with how a modern stack works and things like this. And it seems valuable to go into that direction, but I personally think there is still opportunities for improvement.
Yeah, fine, sure.
And small editorial request, can you add the diff section about the diffs to the original RFC? Like what has changed from RFC 21?
Oh, is there no, okay, yeah.
Okay, so given the discussion, I think we will not run an adoption call in this meeting.
Okay, thank you.
So next is Charles. So this is, as a heads up, this is more an informational talk. It's to be sorted out which working group this draft should target it, but we thought it's of interest to the TCPM community. So that's why we invited Charles to give the talk here.
And you have 14 slides, and we are late in schedule, so consider skipping some of them.
Okay, thank you very much. My name is Carlos Gomez, and I'm going to present this draft entitled TCP over constrained node networks. Closer. Okay, thanks. Thanks to the chairs for offering this opportunity to present this draft here. Thanks. Next, please. Yeah, so about the motivation for this draft, we have that there are several application layer protocols being used for the Internet of Things. One of them is the Constrained Application Protocol, CoAP, which was originally designed over UDP. However, there is a CoAP over TCP specification in progress that's mostly in order to overcome middle box problems. Also, HTTP2 and 1.1 are being used in some specific IoT scenarios as well, and also other non-IETF application layer protocols such as MQTT are also being used. And all of these, the last three protocols or options I've been mentioning, are using TCP. So TCP is being or is going to be used in many IoT scenarios. However, this has not received much attention. Next, please. So the main goal of this document is to offer simple measures to allow for lightweight TCP implementation and operation, suitable operation in constrained node networks. Yeah, just as the chairs mentioned, this is a draft which is related with several working groups. However, the LWIG working group seems to be the one which has been suggested as the possible home for this draft. Next, please. Yeah, so first of all, we should review a little bit which are the main characteristics of CNNs. So constrained nodes are devices which exhibit significant limitations on processing and memory, which limits the complexity and the memory footprint of the protocols implemented, and also limitations on energy resources. For instance, this means devices which run on just a coin cell battery or need to do some energy harvesting. So here communication has to be really optimized in the sense of reducing as much as possible the amount of messages and the size of these messages in communication. Also, these devices typically use what is called lossy links, mostly wireless links, but also there are some wired technologies which are somewhat popular in the IoT scenarios, such as PLC, power line communications, which still are lossy. And with regard to the network topology, we have that sometimes there's a star topology, meaning that there's just a single link between the constraint device and maybe some router or gateway. And in some other scenarios, we have mesh or multi-hop setups. Next, please. So there are several recommendations about which should be the usage of TCP in these scenarios. So first of all, regarding MSS, we have that IPv6 requires support for 1280 byte packets. However, many link layers typically used in the IoT offer very reduced link layer payload sizes, such as tens to a few hundred bytes. That means that in those cases, we need some adaptation layers, such as, for instance, 6LoWPAN, in order to enable IPv6 over these link layers. However, 6LoWPAN, or how it has been used over the different link layers, does not really ensure that packets of a size greater than 1280 bytes are going to be supported. So in order to take care in this regard, we state in the document that the MSS must not be set to a value exceeding 1220 bytes. And in any case, it must not lead to an IPv6 datagram size exceeding that of 180 byte size. Thanks. Next.
Last second, why is this, I mean, why do we need to say anything about this in particular? Because this is just given by what the MSS is. If it's limited by your outbound interface, it's limited by your outbound interface, and that's the limit, right?
Yeah, but
nobody's going to set it to anything higher.
You mean MTU? You said MSS.
Yeah, sorry.
So well, at least, well, I understand there are some links which for which this limitation doesn't exist because they support greater MTU sizes, and in some others they don't. So I think it's important to make people aware, to document that there is this limitation that should be considered.
Actually, answering Lars, last time I looked, there's sort of a missing spec that says that if you do MTU discovery or whatever, if you don't do MTU discovery, but you think you know what the MTU is, you should set DF. There's a bunch of cases where you're actually allowed to do TCP with DF not set, which then has the consequence that you're doing segmentation at 2 levels, which is a bug. There's essentially one missing spec which falls between the layers, which says TCP should always set DF.
Okay.
On a procedural note, my suggestion is we quickly go through the presentation, because there will be further things that might be controversial in the slide. We don't have to sort that out here today. It's more, I think, it's a heads up that there's a certain thinking in certain directions, and we have to sort this out in future.
Okay. Yeah. So another possibly controversial thing is that in the draft at this moment as it is, it's stating that stop and wait operation should be implemented. The reasoning behind this is that there has been a lot of criticism in IoT-related working groups, for instance, in the COA working group, which defines the COA protocol and its related framework, saying that TCP, COAP shouldn't reproduce TCP's complexity for its end-to-end reliability mechanism. So it seems like everyone in more or less the IoT-related community seems to accept the stop and wait operation. So the idea was to somewhat replicate here an equivalent behavior. However, based on the feedback we received, it seems like, okay, maybe we should recommend this kind of stop and wait operation, but maybe not mandate only this stop and wait, and maybe allow somewhat more flexibility. Another matter is how to specifically enable this stop and wait operation. Thanks. So another aspect is the RTO algorithm. We propose in this document that the recommended RTO algorithm for this kind of scenarios should be COCO, which is one algorithm that we have developed. We are still in progress. This is originally designed for the COAP protocol, and it has been designed specifically for IoT scenarios, so it takes into account several specific things that are relatively common in IoT scenarios and which are listed here. Actually, the algorithm is based on the RFC 6298 base mechanism. However, in addition, it also uses weak RTTs, a variable backup factor, aging, dithering, and it gives good performance in several parameters such as PDR, settling time after a burst of messages, fairness, and so on. Nevertheless, RFC 6298 may be used as per this document as it is now. So another aspect is related with the lifetime of a TCP connection. The idea is that we should have long connections in order to actually minimize the overhead of establishing new connections. So currently the draft states that the connection should be kept open if data is going to be sent in the next 2 hours. And on the other hand, there's the keep alive messages which may be used. This might be useful to clean state of inactive connections if we have some constrained devices. However, the keep alive timer cannot be set to a value lower than 2 hours. So in fact, this doesn't guarantee that we are going to avoid problems with middle boxes, which sometimes delete the bindings quite early. So some alternatives suggested here are, okay, maybe the only solution to avoid this middle box problem is to anyway set up new connections more frequently, or maybe application layer hybrid messages can also be used. And based on the feedback we received, it was suggested to consider TCP fast open. However, we need to do some detailed analysis here because some cookie has to be negotiated. This adds overhead as well. The cookie has to be renegotiated with some frequency. So we really need to look into detail to judge whether this is really best or not.
All right, Brian Trammell. So these are constrained nodes. I'm assuming that they're also constrained in power.
They could be, yes.
Okay, so saying that you're going to keep alive more often is probably a really bad idea. Just a comment.
Yeah, but maybe there's no other choice. For it depends possibly on what the middle box is doing. Let's see. So yeah, then about ECN, this may be an option. This could be beneficial to trigger congestion control measures more quickly than just relying on receiving 3 duplicate acknowledgements, if that's a possibility, or maybe waiting for the expiration of an RTO. Yeah, next please. Then about TCP options. In the original form of the draft, we are stating that this has to be a stop and wait operation only. So a consequence is that several options just will not be used or are not useful. So currently the draft says that all these options which are related with the window size, such as window scale, TCP timestamp, selective acknowledgement, just are not useful. So for the next version, probably we need to phrase a little bit different the text about the options, because we anyway have to parse options 0, 1, and 2, and maybe we just ignore options which are not wanted. And if we are not going to be stop and wait only, then we might need to take into consideration other options such as the selective acknowledgements. Please. About explicit loss notifications, this might be useful to avoid activating the congestion control measures when losses are not due to congestion. However, we understand that this remains as experimental work and it has not actually been widely deployed. Yeah, so that's our understanding of the current status of these approaches. And so for the next revision, further items to consider are, for instance, okay, we should clarify the scenarios. Actually, probably the main reason motivating a lot of the activity of using TCP in IoT is to overcome the middle boxes in between. So we may have often a scenario which is a constrained device communicating with an unconstrained device on the internet. So we need to explain which are the implications of this scenario. Then something else is delayed acknowledgements. There was quite some discussion on the list about, okay, should we consider this or not? And if yes, in which way? So we have to find out what is the best approach regarding delayed acknowledgements. And something else is that we would like in this document to collect feedback from people who have actual experience deploying TCP in constrained node networks. There seems to be people who have tried that and have found that performance was really bad. We would like to know why. And if something was working well, we would also like to know why. We would like to collect more or less this implementation experience. So I believe that's all. So thanks a lot, everyone. We got a lot of feedback from this working group, also from other working groups. So thanks a lot for all the great feedback so far.
Last second, so I'm going back to front. So I think you're doing too much in one document.
Okay.
Just based on your last slide, right? So you don't have to put everything in one document. Feedback can be somewhere else. And then the current slide deck, I haven't looked at the document in detail, I just briefly glanced at it as it came in, mixes together things where you recommend to violate existing musts and shoulds, right? Which need to be discussed pretty carefully. And then you are sort of recommending that people, pick a configuration that is already allowed by the TCP protocol standards, right? So for example, the MSS issue, or saying that, don't do window scale or don't do timestamps. That's already allowed, right? And I'm a little bit worried why we specifically forbid this, because there's no harm if an IoT TCP stack chooses to implement this, right? Because if it's trying to negotiate it, it'll fail, and no harm done, right? So explicitly taking it off the table is questionable, I think. And finally, it seems to me that you married yourself to the stop and go approach because you believe TCP is very complicated, but then you optimize the crap out of everything else, like the retransmission timer, right? So that seems weird to spend a lot of logic on differing and all of these things that you do to the RTO. Just give it a few more packets, right? And maybe question whether that's really the right approach.
Yeah, so about the stop and wait, I really believe this is summarizing more or less the sentiment in several IoT-related working groups. I'm not myself really against having more packets. So actually, as in the slide, we are going to give more flexibility about this. Nevertheless, I think it's still useful to indicate, to explain maybe in an informational way, that it's maybe somewhat easy to implement or more lightweight, to have some more simple operation. And nevertheless, I agree that there's no problem in being more flexible.
Gori Fairhurst, slightly like Lars, because I see things like the window size is 1 and then go to use ECN with 1 packet in flight. I mean, like, these are complicated mechanisms you're putting together. Would it be better to start with something really simple that just covers the base thing and then think about something slightly more enhanced rather than taking parts of very complicated mechanisms?
Yeah, thanks. I agree. Actually, for the ECN, it's just a may. So,
I would argue it's a may, but impossible. Conversation afterwards, though.
Okay.
The difficult we do before breakfast, impossible takes a little longer. Colin Perkins, I think for a protocol as big as TCP, where there are so many options and it's grown so much over time, I think the right thing to do is not to sort of say must not implement parts of it, because there was a reason those parts were added, and as the devices become more capable, people are going to want to use them. Say, okay, it's okay to not negotiate them. That way it's more backwards compatible with in future when you want to extend it.
Yeah, I agree. And actually, this is one of the things that have to be incorporated into the document in next revisions. Thanks.
So in general, I mean, we will work with the ADs and the other working groups on how to move this forward. But I think the feedback from the TCPM community is very clear. And I would strongly suggest personally to more focus, first of all, on documenting how you can implement the light by TCP, not by coming up a new TCP variant, which this working group might not like.
Yeah, actually, that's not the intent. So yeah, we don't really want to create some new variants. Yeah.
Lars, like one final comment. Have you looked at TFTP?
Not
because that sort of is very much like what you want. It doesn't have all the bells and whistles, right? And then it's pretty simple. It's stop and go.
Okay. Yeah.
Stop and wait.
Yeah. Thanks.
So we are running late, but maybe we can overrun at least 5 minutes so that Marcelo can at least present the ECN draft.
Hi, Marcelo Bagnolo. I'm going to present this short draft on updating of about enabling ECN on TCP transport control packets. Next slide. So the current situation is that RFC 3168 doesn't allow using ECN on any of the TCP control packets, SYN, SYNAX, PureAX, and Window Pros, and also in retransmit packets. Actually, it provides a number of arguments why this should not be done, and probably we think it's maybe a good idea to revisit them at this point. Next slide, please. So the thing is, the problem of not allowing marking this packet, I mean, using ECN in this packet, is that this results in performance penalties, right? Because basically, when a packet is not ECT capable, that basically means that it has more chances to get dropped when there are congestion events. So, and dropping your SYNs or your AX, it's obviously a performance penalty. So there are a bunch of studies and experiments where this has been shown. Next slide. So I'm going to go now through the different arguments that they use for each of the packets, but there is one overarching argument that is basically about reliability. So RFC 3168 basically says that the congestion signal resulting from marking an ECN, using ECN, must be reliably transmitted. Maybe we think that this may be overly conservative, right? Actually, we think that maybe a more reasonable criteria would be to basically require that the signal, the congestion signal conveyed by ECN when using ECN must be as reliably transmitted as the loss signal, which is what we have without ECN, right? So basically that means that if the packet is lost and is actually detected, then this packet can, if the packet is lost, the congestion signal must be using ECN must be as reliable as the detection of the packet loss, right? So this argument is used to avoid, for instance, marking PureAX, using ECN in PureAX, right? So basically because some of the PureAX are just lost and the endpoint doesn't detect that. So if you actually mark that PureAX using ECT and it's eventually marked with the CE bit, and if the packet is later dropped, you will not be able to detect it. So what we think is we should move to this do not harm, like not worse than today situation, where if the packet is, you should be able to enable all packets to be marked, and if the packet is lost and the CE is lost, you will basically be detecting the same congestion signal that you're detecting as of today, right? So basically we think that this whole argument can be safely removed. Next slide. So there's a bunch of specific arguments for each of the type of packets that I'm going to try to go quickly now, right? So in particular for SYN, the first argument is that you don't know the capability of the responder, so the SYN with the market packet could actually, the SYN with ECT could be actually discarded by the responder. So there is an analysis from Brian and Miriam that basically shows that at least, 99.2 of the top 1 million Alexa sites actually respond with some form of SYNAC, if I understood the paper right. Right? So that basically leaves us with a 0.8 that do some other stuff. Right? So what do we do with, so for the 99.2, we are kind of okay, right? And for the rest, they most of them basically they silently discard. So what do we do in this case? So actually, if they silently discard that, basically you're exchanging the possibility of a drop of a congestion by the possibility of silently discarding you, which is not really great. Right? So, but the main difference is that with policy discarding, you can actually learn which ones are those, right, and cache those, right, while the congestion is unpredictable, right? So we believe that actually using caching in this situation, since the percentage is so low, may actually help you to do this. Next slide, please. The second argument is actually the reliability argument, where this is the only case I actually believe it actually holds, is that if you send a scene with the ECT and is actually marked with CE, and the respondent doesn't support the ECT in the scene, that congestion signal will get lost, right? Because you will get the SYNAC, but you will not get the feedback whether there has been congestion or not. So actually, this would actually happen with all these responders that do not support the ECT marking of the scene. Probably, again, using caching in these cases and avoiding using the ECT in the scene for those particular sites, it's the way to go. Next slide. The third argument is about denial of service. So this argument I actually copied literally here because I have a bit of a hard time to understand, because basically they talk about DOS, TCP SYN flood attacks, right? And then they talk that it may congest the router. So it kind of talk about the TCP SYN attacks are attacks against the endpoint, but he actually talks about congesting the router. So I'm not very clear which one of those. So I actually addressing both of them here. So actually, making this, using ECT to make a TCP SYN flood attack to the endpoint more aggressive, well, actually, I would argue that if an attacker wants to do this, he will actually set the ECT bit anyway, right? Because since the RFC doesn't actually require the routers or firewalls to drop this, right? If I'm an attacker and I'm already misbehaving, right, I would probably mark them anyway, right? So, and the second thing is the argument of not setting ECT in order to prevent DOS attack, that actually applies to any packets, because these flooding attacks can be launched with SYNs, but with other types of packets as well, right? So that argument would actually hold for any data packet, I guess. And in terms of the attack to the router, RFC 3168 already mandates that AQM must be turned off if you have a persistent overload, which seems like the reasonable way to go in order to prevent this. So that's already in the document, and we probably believe that this is the right thing to do in order to prevent those attacks against routers. Next slide. So pure acts, the first argument is the reliability argument. We have already been through that. The second argument is that the receiver of the one who is sending the pure acts has no ways to react, may not have ways to react to congestion since he's only sending pure acts, right? So first, it's not always true. He may be sending some pure acts and some later on maybe he's sending packets. So he actually, in some cases, he could do something. And the second argument is you're not worse off than today, right? Because as of today, you lose the act, you don't do anything, right? In this case, you may be able to do anything. So at least you're as bad as today, right? So probably, sorry? You could. I don't know if that's a lot of load. Next, retransmit packets. First, the reliability argument. We've already been through that. Second, DOS attacks. The DOS attacks basically are saying, okay, so I'm using the CE bit to force the receiver to reduce the congestion window, right? And the first is, again, if I am an attacker, I will set the CE bit anyway, right? I just don't care, right? Because you cannot find out. And the second, the real protection against this is already in the RFC 3168. That is, don't react to out-of-window packets, and probably that's a real protection against this. Next slide, please. Window probes. The only argument for this is the reliability argument. We already been through that. Next slide. So this is a summary of all the arguments. Next. And Next steps is, okay, so what do you guys think we need to do? So I don't know if people have other arguments about this, about why they should not be marked, about why they should be marked, and yes.
Hi, Brian Trammell.
So
Thanks for the document.
just a quick comment. First of all, if you haven't signed the blue sheets, please do so now.
Okay. And I'll make this super quick. We should probably take it offline. I wrote a thing to the list saying, oh, there's one more argument. You're breaking all of our wonderful measurement experiments, including the one that you cited here, which makes me sad as a researcher, but if it makes the internet better, I don't really care. However, the measurement techniques that we use are the same measurement techniques that can be used at runtime to figure out whether or not you're on a network where you need to fall back or cache some information about that network, about how broken ECN is. So any recommendations that come out of this document need to very carefully make sure that they're not making things legal that where the trade-off is that, okay, well, now we used to be able to differentiate this is a path on which ECN is broken from this is a path on which there's this new shiny way to mark things. So marking on the SYN is probably fine, but we need to be careful about marking on the SYN-ACK. I mean, there's some detailed work that needs to be done here, and I've looked through the drafting, and I think it's possible to do, but it absolutely needs to be done.
Okay.
I realize I just volunteered for a thing.
That was short. All right. All right. Two quick points.
Sorry. What's your name?
Dave Todd.
Okay.
The overall. I tend to regard the lack of ECN markings on certain control packets as a feature rather than a bug.
Okay.
And as you use two examples, SYNs, if SYNs are not getting through because there's so much congestion, and then that acts as a form of primitive admission control to add less load to the network. The second one is that although this is the TCP working group, there are other protocols that are relying on loss, and the more and more that we have a steady, reliable stream of undroppable packets, that does push hard on the other packets that may be dropped in other protocols.
Okay, so first, I mean, clearly where you have ECN, you can also have a drop, right? If you run out of buffer, you can actually have a drop, right? It's not like ECT packets are undroppable, right?
Yes, you can, but the thresholds for doing so on a well-behaved network in equilibrium tend to be high, push against the other protocols.
I agree. But the argument of not doing TCP better because other protocols are not better, I have a hard time buying that one.
Yeah, Bob Briscoe, responding to Dave's point there, the protection against when you have overload, you turn off ECN. You said that, right? You said that's quite a high threshold, but that is the point, that you only need that real backstop against total collapse when you start moving into a loss regime when ECN gets turned off. Yeah, but that's very important. That's the most important congestion control in the internet is loss. But when you're in a normal regime, you don't want to be dropping the SYNs that could well be all the data in your flows. That, you know, because they're short flows. Yeah. Yeah. Right. Yep.
Okay, so anyway, I've seen on these slides the word L4S, so I assume there is another opportunity at this IETF to discuss certain aspects in that space here. So we are over time.
No, that's fine. I don't think we're discussing this in L4S. I really welcome if people comment on the mailing list.
Yeah, as I mean that there has been interesting feedback. I mean, this is probably something we should further discuss. It also has to be sorted out which working group. This is another formal issue to be thought about. So, but anyway, I mean, we have time to discuss this either this IETF or in the next one. So for the moment, the mailing list just seems a good place for this. And we had the low RTT talk on the agenda, but this hasn't received any mailing list feedback. So I suggest to take this to the mailing list. So with that, I think we are done. Thanks a lot for all the interesting discussions, and see you then at the next IETF.